Alright, so for this last part of Unit 8, we're going to do what's called applications of linear systems. Basically, that means we're going to solve word problems. Okay, so we're used to doing the ones where they give us the two equations and we solve it. Now we have to actually write our equations from the word problem and then solve it. Okay, so here are some helpful tips for you. Okay, number one, highlight or underline the important information. Okay, number two, it's going to help to define your variables, and meaning what do they represent. And it's going to be helpful, instead of always using X and Y, maybe using letters that stand for things that it stands for. Step 3, you're going to write your two equations with your variables. Step 4, you're going to solve it. Step 5, you can always check your answer. Step 6, because we're talking about things, try to remember your units or what you're talking about. Okay? So we're going to talk about 4 types of problems. Okay? Number 1. This problem says the sum of two numbers is 34 and their difference is 14. Find each number. So in this case, I can use X and Y. Okay, so I'm going to use X for a variable and Y for a variable. But let's think about what those things are standing for. I'm finding two numbers, right? So I'll just call X will be the first number and Y will be the second number. So now I'm going to go and set my equations up. Okay? And so I'm just going to make the math match what it's saying. Alright? And sometimes that, it's keep the pieces together. This part says the sum of two numbers is 34. So remember what sum means? It means to add. So that means if I add up the two numbers, X plus Y, it is or equals 34. That's my first equation. I don't know what X and Y is, but if I add them, the sum is 34. Now this next part will be the other part of the system. Their difference is 14. Remember, difference means minus. So it's like if I minus these, the difference, subtracting them, is 14. That's my system. That's it. Okay, so now when I start solving it, let's take a look. See if it's easy or if I have to do any work. Oh, this is an easy one because the x's won't go away. Hopefully you notice they're both positive. That will not go away, but look, positive y, negative y. Those will cancel out. So then, now I combine. Now be careful here. A lot of people see the x and the x and they put x. No, this is x plus an x. And if you want to put the 1, go ahead. 1x plus 1x is 2x. Then I bring everything down. 34 plus 14, because it's positive, is 48. Okay? Now I'm kind of out of space, so I'm going to bring it over here. 2x equals 48. Divide both sides by 2. And x equals 24. So see, once we have it set up, that's the only hard part now. Now you know how to solve it. And then remember, I need to take this and plug it back into one of the equations. So I'll plug it back into the first one. X is 24 plus y equals 34. Solve for y by doing minus 24. And y will equal 34 minus 24, 10. Okay? Now in this case, I don't have to write my answer like a point because I'm solving a word problem. Alright? But in this case, the x was 24, the y was 10. That means the first number was 24, the second number was 10. Okay? Alright, next one. Okay? This one says Stefan's school is selling tickets to a concert. On the first day, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. So now, X and Y might be confusing. Okay, so what are we talking about here? Well, once again, let's get all these important numbers. 3, 1, 38, that's important. 3, 2, 52. I need all these numbers, right? What are these numbers talking about? 3 senior citizen tickets, 1 child ticket. I'm talking about tickets. So to label them, it might help to say S for senior citizen tickets, and then C for child tickets. That way I know the difference between the 2 tickets I'm talking about. Okay? So I'm going to use S for senior citizen tickets, C for child tickets. So now when I set this up, now think about how the story is kind of modeled. I'm going to have 2 equations. And see how this problem is talking about 2 days, right? So I'm going to make the first day be one equation. On the first day, the school sold 3 senior citizen tickets and 1 child ticket for a total of 38. So 3 senior citizen tickets times each one. I don't know how much they cost, right? That would be 3S. 3 tickets times how much the senior citizen ticket cost, I don't know. Plus, they sold 1 child ticket, and that equaled a total of $38. See, this is what the first sentence said. Okay, this is the money, this is the total. 3 times how much they cost plus 1 ticket times how much it cost equals 38 total. Now I'm going to go to the second sentence and make my second equation. Now you see what they did? They kind of tried to be tricky a little bit. They put the 52 first. That's the total. So I'm going to put the 52 here for the total. Because remember, I want my S's and C's to line up. This is 52 is not for the senior citizen or child ticket. It's the total money. Now what did they sell? 3 senior citizen tickets. So there's 3S again. And plus 2 child tickets. That's my system now. Okay, so now I want to start eliminating. Now, hopefully you slow down a little bit. I can't cross the S's out. They're both 3, but they're both positive, right? So what I want to do is I need to multiply everything by -1, because 3 times -1 is -3. So I can multiply either one. Okay, you could do the first one or the second one. I'm just going to choose to do the first one. So when I do that, -1 times 3S is -3S. -1 times +1 is -1C equals -38. Nothing happened to the second equation, so we just bring everything down. 3S plus 2C equals 52. That's the hard part. Now look, now the S's will cancel out. -3, +3. Alright? And now this is all the solving from what you've done before. So you're going to combine it, find the C, which is the child ticket, plug it back in here to find the S or senior citizen tickets. Alright? So take a moment, pause the video, finish it, and I'll unpause it to see the answer and go to the next one. Alright, so here's the steps, but the final answer was C is 14. That means they sold the price is $14 for a child ticket, $8 for a senior citizen ticket. Okay? And if you need to go back and look, these are the kind of steps. Solve for C first, plugged it in, solve for S. Alright? Now the next type is a little bit different. Okay, you have to approach each problem a little differently. Number 3 says you are selling tickets to the football game. Youth tickets are $2 and adult tickets are $6. You sell a total of 800 tickets and collect $2,800. How many youth tickets and how many adult tickets did you sell? So here's the thing, our variables now. We're talking about A for adult tickets and Y for youth tickets. But here's the difference, and I wasn't specific enough. This problem we're talking about how much the senior citizen and how much the child tickets cost. Here we're talking about how many we sold. Okay? So when we go back through here, let's highlight the important stuff. Youth are $2, adults are $6. You sell a total of 800 and collect 2,800. Now this one's different, okay? So remember we kind of talked about? Let's put the same things together. So do you see what's kind of the same? Money, money, money. I'm going to make one equation all about the money. So I'm going to do youth is 2. So that's 2Y. It's $2 times how many, I don't know. Plus 6 adults. $6 times how many adults, I don't know. And that equals $2,800. So I did the $2, the $6, $2,800 all together. Money, money, money. That's how to make it easy. Now, what's left is this 800. It says they sold a total of 800. The total goes on the right side. But now I'm not talking about money. I'm talking about how many. And remember, this is how many adult, how many youth. So this is kind of the weird part. I'm going to just do youth plus adult equals 800. This means the number of youth tickets plus the number of adult tickets equals 800 total tickets. So this is the money, money, money. This is the tickets, tickets, tickets. That's how this one's a little different. Okay? So now what we're going to do here is get ready to multiply to eliminate, because right now, none of these will eliminate the way they are. Alright, so remember, when you're doing it on your own, you could choose to get rid of the y first or the a first. Doesn't matter, okay? But since we're doing it together, I'm just going to choose to get rid of the y first, right? So this is a 2y. Right now, this is a 1y. So what would I multiply 1 by to make it the opposite of 2, or negative 2? So I'd multiply by a negative 2, because negative 2 times 1 would be negative 2. So I'm going to do the whole equation on the bottom. So that means the top equation does not change. So it's still 2y plus 6a is 2,800. Now the bottom, negative 2 times y is negative 2y. Negative 2 times 1a, negative 2a. Equals negative 2 times 800 is negative 1,600. So now we did that. Now we can start canceling. The y's cancel. I'm out of space. I'll come here, but I'm going to combine it. 6a minus 2a, 4a. Alright, and then you can continue. So pause it, finish it, and let's compare the answers here. Alright, and so the answers for number 3, adult tickets, there were 300 adult tickets. Youth tickets were 500 tickets. And here's the work. Okay? Alright, the last type of word problem you see, this is dealing with perimeter. Okay? So this tells us the perimeter of a rectangle is 82 yards. The width is 15 less than the length. Find the length and width of the rectangle. And they will always give you this perimeter formula. You don't have to memorize that. Okay? So here's what we're going to do. They're actually giving you half the equation. Or one of the two equations, I should say. So remember, we're finding the L, which is the length, and we're finding the W, which is the width. So those are our two variables here, length and width. So if I take this, 2L plus 2W equals the P, and P is for perimeter. Well, let's go back and look. What is the perimeter? I don't know the length and the width. That's what I'm finding. But it says the perimeter of the rectangle is 82. There's my first equation. This is the hard part. Okay, and this kind of goes back to chapter 1. So if you need to get your pieces, it says the width is, remember is the equal sign? So W is, or W equals, 15 yards less than the length. Less than is minus, so it's 15 minus the length. Now hopefully you also remember, when they say less than more than, that's when I switch the order. So when I write this equation, it's going to be W equals L minus 15. And if that looks like a 1, you can make it a capital L. So these are my two equations for my system. Okay? Now if you think this looks funny, you're right. It's not ready to solve. We haven't had to do this a lot, but remember we have to have like the L's with the L's, the W with the W. So I got to change this equation first. Okay? So I'm going to come here to the side, W equals L minus 15, and I want this to look like this. I need to move the L over here. So how do I move this L? I do minus L on both sides. So I'm going to put the L first, negative L plus W equals negative 15. So now when I put this over here, negative L plus W equals negative 15. Now I can do this. Now I'm ready to go. But nothing will cancel. So like always, if nothing will cancel, let's make it cancel. 2L, negative 1L. So if I multiply this by 2, it'll be opposites. So nothing happens to the top equation. But the bottom, everything will be times 2. So 2 times negative L, negative 2L. 2 times W, positive 2W. Equals 2 times negative 15 is negative 30. So now look what we got. Now I can eliminate. 2L minus 2L, L's are gone. Combine. 2W plus 2W is 4W. Equals 82 minus 30 is 52. Alright, pause it. Try to finish it, and let's compare answers. Alright, so if you finished it, you should have gotten the width is 13 yards and the length is 28 yards. And here's the work. Okay, so now it's time to do some practice on your own, but all you're doing is reading the information, setting up all the parts into two equations, and then you're trying to solve it by canceling. If nothing will cancel, do your multiplying. Okay? So it's the same solving, you just have to make the problem now.